Lesson 3.5, solving quadratic equations by completing the square. Best standards are MA 912, AR 3.2, 3.4, and 3.8. So previously we learned about square root properties, and we could take the square root of both sides. So the square root property stated that in the form of x squared equal to n, you would take the square root of both sides, causing a positive and negative situation. When we come to completing the square, like in example 1, we're applying the square root property as part of it. So it says solve x squared minus 4x plus 4 equal to 25 using the square root property. First thing they did, they noticed that the left side, that is a perfect square trinomial. So they were able to collapse it to x minus 2 squared equaling 25. Then they applied the square root property, which means they took the square root of both sides, causing the binomial of x minus 2 squared to become just plain x minus 2, and you have the square root of positive and negative square root of 25. So that becomes a 5, and then you add 2 to the other side. That's where we get x equals 2 plus and minus 5, so we have two sides of it, 2 plus 5 or x equaling to 2 minus 5, where we have a situation of 7 and negative 3. So the solution set's going to be negative x, where x is equal to negative 3 and 7. Okay, in example 2, it says x squared plus 24x plus 144 equals 192. Again, we're going to apply the square root property. This is going to cause irrational properties to happen. So again, they collapsed x squared plus 24x plus 144 as the perfect square trinomials to become the parentheses x plus 12 squared equaling 192. Then they took the square root of both sides. So we have x plus 12 is equal to positive and negative square root of 192. Okay, square root of 192. You have to remember the factors of 192. First, 1 plus 9 is 10, plus 2 is 12. If you add up the digits, there's 12, so it's divisible by 3. So 192, if I divide by 3, I get 64 and 3, which means I can then take the square root of the 64. That's where we got the 8 square roots of 3. That's where they ended up with the positive and negative 8 square roots of 3. We subtract our 12 over, so I have negative 12. So I could be x equals negative 12 plus 8 square roots of 3 or negative 12 minus 8 square roots of 3. Then, using a calculator, you can figure out the solutions for x, and you type in negative 12 plus 8 times the square root of 3, and we end up with our 1.86. And then if we do negative 12 minus the 8 square roots of 3, then that's where we end up with our negative 25.86. In example 3, it says solve 2x squared minus 92x plus 1058 equaling negative 72 using the square root property. So the first thing we're going to do is we divide each side by 2. So I'm dividing every piece by 2, which reduces my problem to x squared minus 46x plus 529 equaling negative 36. Then we're applying the properties of perfect squares. So 529, if you take the square root of 529, that is actually equaling 23. So this collapses as a perfect square trinomial. In the pattern of a plus b squared. So that's where we get our x minus 23 in parentheses squared equaling negative 36. We then take the square root of both sides, where we become x minus 23 equaling positive negative square root of negative 36. Now, square root of negative 36, remember that's the I value. When you take the square root of a negative number, we are using the I piece. So it's x minus 23 equaling positive negative 6i. When we add 23 over, we become x equals 23 plus and minus 6i. So we can be 23 plus 6i or 23 minus 6i. Again, in a calculator, you will not get a exact answer since this is imaginary pieces. Solving quadratic equations by completing the square. So completing the square, it's when we take manipulate the equation to one side to be a perfect square, and we call it completing the square. In order to do that, we need to first be in the form of x squared plus bx. So we need to follow this procedure right here. Step 1, find the half of b, which is the middle term. That becomes your coefficient. We're going to take the square of that result in step 1, then apply step 2 to x squared plus bx. So in order to do that, we are going to go through a problem. So it says in example 4, complete the square. Find the value of c that makes x squared minus cx plus c a perfect square. Then write an expression as a square of the trinomial. So first it says find half, 1/2 of -7. So remember that's the same thing as saying -3.5. We can write it as a decimal form, or you can leave it as a fraction. So I'm going to follow the fraction format so that it makes more sense. So we have x squared minus 7x plus a c. We then divide by, again, we're taking that b term. The b value is -7. You divide by 2, and then you square it to become the c. So that's 49 over 4. So I have x squared minus 7x plus 49 divided by 4. So if we were following the decimal side version that they wanted us, when we squared 3.5, we ended up with a value of 12.25. And then we would add it to our p, so then we become x squared minus 7x plus 12.25, which we would collapse as x minus 3.5 squared. But since I'm using the factored sign, when we collapse this to the power of 2, we become x minus 7 over 2. In example 5, it says solve x squared plus 18x minus 4 equals 0 by completing the square. So first thing, we started with the original problem. We are going to first add 4 to the remaining side. So we moved it over and we added 2 blanks. The blanks are where we're going to add our b divided by 2 piece. So our b is actually an 18. So we're doing 18 divided by 2, which equals 9. And then we square it. So we're adding an 81 to both sides. Then we are applying the factor rule, or perfect squares. So we become x plus 9 squared equaling 85. We now then take the square root of both sides. So we get x plus 9 equaling positive negative square root of 85. Square root of 85 is not a perfect square root, so we become our -9. We subtract our 9 over, so it's -9 plus and minus square root of 85. So we have a -9 plus the square root of 85 and a -9 minus the square root of 85. When we put those into the calculator easily, decimal-wise, we become 0.22 and -18.22. I would have just left it as the setup piece. In example 6, it's solve a problem by completing the square. So it says Jamal's parents are putting a rectangular swimming pool in their backyard. The length is 16 feet longer than the width. If the pool will cover 512 square feet, find the length and width of the pool. So again, x represents the width. So x plus 16 is going to represent the length of the pool. Since here the rectangle is length times width, we see x times x plus 16 equals 512. We're going to use a distributive property, so we dove in, and we become x squared plus 16x equaling 512. Again, now in the situation where we are here at the situation x squared plus 16x, I'm putting a blank equaling the 512 plus a blank. Reason being, we're applying the completing the square piece. It's taking 16 divided by 2 gives you 8, which we square is 64. We're adding 64 to both sides. That's where these 64s come from. Then we're going to use the factor rule, perfect squares, and collapse it to become x plus 8 squared equaling our 576. Then we are taking the square root of both sides. So we get x plus 8 equaling positive negative square root of 576. Again, 576 is a perfect square root. That becomes 24. So we then subtract 8 over, and we get negative 8 plus and minus 24. So we have negative 8 plus 24, or x equals negative 8 minus 24. So our possibilities are x equal to 16 or x equal to negative 32. But remember, width cannot be negative, so x equal to 16 is our only visible dimension. So the dimensions are going to pull are going to be 16 feet for the width, and then 16 plus 16 or 32 feet for the length. Okay, in example 7, it's solving when the a value is not a 1. So it says solve 4x squared minus 12x minus 27 equals 0 for completing the square. So the first thing we're going to do is we're going to divide each side by 4. We are dividing every piece by 4. So we get x squared minus 3x minus 27 over 4. Yes, we leave it as a fraction. We're going to add 27 over 4 to both sides. We're applying our b squared. So remember, b in this instance is negative 3. So we're doing negative 3 divided by 2 and then squaring, and that's where we get 9 over 4. So we're applying 9 over 4 to both sides. We're applying our perfect square trinomials. So the middle piece on the left just collapses to x minus 3 over 2 squared, equaling 27 plus 9 is 36 over 4, which is also the same thing as saying 9. We're going to take the square root property, so we're taking the square root of both sides in this instance. So I'm saying x minus 3 halves equals plus and minus 3. We're adding 3 halves to both sides. So we have x equals 3 halves plus 3, or x equaling 3 halves minus 3. When we get to this point, you're doing your fraction pieces, so think of 3 halves plus 3 over 1. If you do the products, this gives you 3. These give you 6, and then there's a plus sign between them, divided by 2, and we get 9 over 2 for the first one. If we do 3 halves minus the 3 over 1, same situation. The product here is 3. The product here is 6, but there's a minus between them, over 2, and we get negative 3 over 2. In example 8, it says solve equations with imaginary solutions. So it says solve 3x squared minus 72x plus 465 equal to 0. Again, we're starting with the original, and since the leading coefficient is not 1, we're going to divide each side by 3. So we divide it by 3 and we get x squared minus 24x plus 155 equaling 0. Then we're going to subtract 155 to both sides. So it's negative 155 on the right now. Again, we're doing completing the square. The b value in this instance is negative 24. So we're dividing by 2 and then squaring it. So we become negative 12 squared, which is 144. So I'm adding 144 to both sides. When we collapse it, and we're going to get x minus 12 in the parentheses squared, equaling negative 155 plus the 144 makes it negative 11. We're then going to take the square root of both sides. So we get x minus 12 equaling plus and minus the square root of negative 11. So again, square root of negative 1 is I. That's where we end up with x minus 12 equaling plus and minus I squared is 11. We add 12 over. So I get 12 plus and minus I squared is 11. So our two equations would be 12 plus I squared of 11 or 12 minus I squared of 11. Learning quadratic functions in vertex form. In previous lessons, we established the formula that said y equals a parentheses x minus h squared plus k. So in example 9, they want us to write functions in vertex form. So I'm going to explain it a little bit different than the way it's written for you. So on A, it says y equals negative x squared minus 12x minus 9. The first step we do is actually add the 9 to the left side. So we become y plus 9 plus a blank equals negative parentheses x squared plus 12x plus a blank. In this process, I factored out my negative so that I can do completing the square. Completing the square says we're going to take that middle term, which is 12, divide by 2, and you get 6, which you squared is becomes 36. So I'm adding 36 to the inside, but because I have that negative on the outside, it's going to be negative 36 to the left side. So now we become y minus 27 equaling negative parentheses x plus 6 squared, because I use power perfect square trinomials. And then I'm going to add the 27 back over. So in vertex form, it's y equals negative parentheses x plus 6 squared plus 27 for letter A. In letter B, it says y equals x squared plus 8x minus 3. And I'm going to apply the same premise. So for B, we start out with our equation, x squared plus 8x minus 3. We add our 3 to the left and add our blank. So y plus 3 plus blank equals, we have x squared plus 8x plus a blank. Notice we didn't have to factor out a negative because it was positive at the beginning. We're going to apply completing the square, which says the middle term is 8 divided by 2. That is 4. Squared is 16. So I'm adding 16 to the left, which means I balance by adding 16 to the right. The left side becomes y plus 19 equaling x plus 4 squared. And then we subtract our 19 back over. So it become y equals x plus 4 squared minus 19, which is the same result they had for their version of B, just a different method. On example C, it says y equals negative 2x squared plus 4x plus 7. So again, on C, I started out with our original, which is y equals negative 2x squared plus 4x plus 7. I start by first subtracting the 7 to the left side and adding my blank. Y minus 7 plus blank equals, now I'm factoring out a negative 2 out of this. So I become x squared minus 2x plus a blank. Because remember, we are isolating that negative out. When we go to completing the square, we're going to do negative 2 divided by 2, which is a negative 1 squared is equal to a positive 1. So I'm going to put a positive 1 on the inside. But remember, on the left side, this negative 2 is being multiplied by that 1. So I'm giving the left side a negative 2. We combine our like terms and we get y minus 9 equals negative 2. Collapse our bubble to become x minus 1 squared. And then the last step is add the 9 back over. So we become y equals negative 2 parentheses x minus 1 squared plus 9, which is the same thing they did. In example 10, it says determine the vertex and axis symmetry. So they gave us a problem that says consider y equals a 3x squared minus 12x plus 5. They want us to write it in vertex form. So I'm going to go the route that I would have gone to get to our solution. So we had our original y equals 3x squared minus 12x plus 5. Again, start by subtracting that 5 over. So become y minus 5 plus a blank equals, I'm factoring out a 3. 3 parentheses x squared minus 4x plus a blank so that you can do completing the square. Since it's negative 4 in the middle, it's negative 4 divided by 2, which is negative 2 squared, which gives us 4. So I'm adding 4 to the bubble on the left right side, but to the left, remember it's 3 times that 4, which makes it a 12. And then we get y plus 7 equals 3 parentheses x minus 2 squared. And then we subtract our 7 over to end up with our problem, which is y equals 3 parentheses x minus 2 squared minus 7. Again, remember the axis of symmetry is based on our vertex. The axis of symmetry is based on our vertex. So think of x minus 2 set equal to 0, so x equals 2. So our axis of symmetry is a 2, which makes our x value of our vertex a 2. And then the y value of our vertex is the last number, the last digit, which happens to be a negative 7, would be the y position of negative 7. Because the beginning value of our parabola is a positive 3 at the beginning, we are opening up, which means we have a minimum. In example 11, it says using quadratic functions. So fireworks, it says if a firework was launched 1 foot off the ground at a velocity of 128 feet per second, write a function of the situation, then find and interpret the axis, symmetry, and vertex. So we're going to use the function for projectile motion, which is h of t equaling negative 1/2 g times t squared plus vt plus h naught. H naught is your initial height. So in this instance, they're telling us our g is 32 because they told us that we're going at 182 feet per second. That's where our velocity is at. 32 is a constant value that's always present. It's always going to be 32. So we're taking half of that, making it negative 16 t squared plus 128 t plus 1 to start. In part 2, they want us to rewrite the function in vertex form. So we start with our original equation. Now we're saying y equals negative 16 t squared plus 128t plus 1. Think of what we were doing completing the square. First thing we're going to do is subtract our 1 over. So become y minus 1 plus a blank equals, factor out that negative 16, and we get negative 16 parentheses t squared minus 8t plus a blank. We're going to do completing the square, so we're going to do 8 divided by 2, that is 4. 4 squared is 16, so I'm adding 16 to the right, but remember that 16 on the outside is being multiplied, so I'm writing negative 256 to the left. Combine our like terms, we get y minus 257 is equal to negative 16, collapse, so t minus 4 squared, and the final step is to add the 257 over. So we get y equals negative 16 parentheses t minus 4 squared plus 257. In step 3, it says find and interpret the axis of symmetry. Because the axis of symmetry divides the function into 2 equal halves, the fireworks will be at the same height after 2 seconds as it is after 6 seconds, because remember, we are doing plus and minus 4 seconds from our start point. Step 4 says find and interpret the vertex. So our vertex is the maximum number of the function because a is less than 1. So the firework is going to reach a maximum of 257 feet after 4 seconds, because our vertex, again, t minus 4, think of t minus 4, set equal to 0, we get t equal to 4. So we have a vertex value of 4, 257.